Okay, for what we have in number 6, okay, we're looking at determining the volume of the solid rotated about the x-axis given that y squared is equal to the square of the ratio of 8 minus x to 1 plus x. And if you were to graph, you could either graph the positive or the negative of 8 minus x over 1 plus x if you were to take the square root method of the original ratio, where y could be equal once again to 8 minus x all over 1 plus x, or it's negative. And what I chose to do was to graph this particular function, in other words the upper half of what makes up y squared is equal to the square of the ratio of 8 minus x to 1 plus x. And so for what we have in the first quadrant, okay, you had this particular curve, okay, in reference to y is equal to 8 minus x over 1 plus x. Okay, so among the key points we have from 0, 8 to 1 and 3.5, and we are looking at going from x equals 0 to x is equal to 1. And for the solid, that is going to be formed, okay, right, again we have continuous contact with the x-axis, and with the solid we're going to be able to use the method of disks. Okay, and now for what we have for the three-dimensional counterpart, again rotating about the x-axis, okay, we're going to end up with the ratio as the height of this two-dimensional graph, which we have as 8 minus x all over 1 plus x. And with the method of disks, okay, again going from x equals 0 to x equals 1, and considering that disk is making to reference the area of a circle, namely pi r squared. Okay, for the disks, okay, we're going from x equals 0 to x equals 1, pi times the square of the radius. We were looking at the square of 8 minus x over 1 plus x. And for what we have in the case of setting up what we have in the ratio, now we're going to be looking at integrating over the algebraic part, namely the square of the ratio 8 minus x to 1 plus x. I'll get back to this particular part, but for what we have in terms of the integration, okay, we have for the square of 8 minus x to 1 plus x, okay, if we square both the numerator and denominator, okay, we get 64 minus 16x plus x squared all over 1 plus 2x plus x squared dx. And here we have the same degree in both numerator and denominator, and we can set up integration. Okay, and before we get to the partial fraction decomposition, we can look at the long division. And so for taking x squared plus 2x plus 1 into x squared minus 16x plus 64, again arranging both the numerator and denominator in descending degree order, it's going to follow that with the long division. Okay, we have x squared into x squared is 1, multiplying and deducting the product from the numerator. Okay, we have negative 16 minus 2x, which would be negative 18x. 64 minus 1 is going to be at 63. And so for what we have in the quotient is going to be 1, and the ratio or the remainder is going to be negative 18x plus 63, which that's going to be the ratio as the numerator over the square of x plus 1. And so for what we have in the makeup here for the integration of this ratio, we have 1 plus the ratio and separating. Okay, we have the integral of 1 dx, and then we have minus 18x plus 63 over the square of x plus 1 dx. And for the antiderivative of 1 dx, okay, this is going to go to x itself. And as we look at separating, okay, we're going to have initially, okay, we have looking at the partial fraction decomposition portions. Okay, we have, okay, so you have the antiderivative of dx is going to go to x. Now for just reestablishing how we're going to come to these terms, okay, we have, right now we have negative 18x plus 63 over the square of x plus 1. So you have a over x plus 1 plus b over the square of x plus 1, clearing away the fractions. Okay, we have negative 18x plus 63 is equal to a times the quantity of x plus 1, followed by b. Okay, again, we have the least common denominator present in both of these fractions. So as we clear away x plus 1 underneath a is still going to be distributed over x plus 1. And there's only one real zero that exists, and that is in reference to x is equal to negative 1. So negative 18 times negative 1 is positive 18 plus 63 is going to be 81. Okay, and with a zeroed out, okay, this is what b automatically is going to end up coming to. And if we were to solve for a, okay, we can choose an arbitrary value for x, and since we are solving for 1a, we can just set x to 0, and in this one we have 0 plus 63 is 63 is equal to a plus b, and b already determined to be at 81. We have 63 is equal to a plus 81, and from this it is going to result that the value of a is at negative 18. So once again we have a over x plus 1, a is at negative 18, b is at 81, which b was originally over the square of x plus 1. And so for the partial fraction decomposition, okay, again, this is going to be carried all the way over to negative 18 over x plus 1 plus 81 over the quantity of the square of x plus 1. And so this is how these last two integrals are going to end up coming about. And so we have originally from the line division 1, where the antiderivative ends up at x, and then for what we have from the partial fraction decomposition, okay, we have negative 18 all over x plus 1 dx, and then we had 81 over x plus 1 quantity squared dx, and I took out the coefficients, just put in front of the fraction, or the reciprocals. So we have negative 18 times the integral 1 over x plus 1 dx plus 81 times the integral of 1 over x plus 1 quantity squared dx. And for the antiderivatives, again from 1 at the beginning we have x, we have minus 18 times the natural logarithm of x plus 1, and then we have 81, and the antiderivative of the reciprocal of the square of x plus 1 is going to be at negative 1 over x plus 1, and so we have x minus 18 times the natural logarithm of x plus 1 minus 81 over x plus 1. And so going back to the original problem, okay, looking at the volume generated about the x-axis, for what we are going to end up with in this particular case, again, we have the integration and we're going to multiply by pi. So in looking at going back, once again we had the volume going from 0 to 1, pi times the square of the radius, and after the long process of taking the integral of the square of 8 minus x to 1 plus x, okay, we have in this one, you're going to have for the volume, okay, this will be as x goes from 0 to 1, and you have a pi, and then again from the prior integral that we had attained, okay, we have quantifying, we have x minus 18 times the natural logarithm of x plus 1 minus 81 over x plus 1 as x goes from 0 to 1. And there are various ways upon which the volume can be determined. And now if you were to keep it so close to exact form as possible, one version is that we had the volume is going to be equal to 83 halves pi minus 18 pi times the natural logarithm of 2, or as a decimal approximation we have about 91.18 cubic units.